12.
Do you see this?
With the
Do you
video.
see this right now?
You could have taken us with the video.
I can't ask the video questions.
That's true. You can, but the video won't answer back.
If you didn't come in today, like someone, then
Okay. Here we go. All right. Here we go. We're going to do, I think 3. Okay, we'll do 3 maybe. Here, 3 graphs. Yeah, just get an idea. Just get an idea, okay, of what it's like. Okay, because it's similar in that we're going to do the graph the way we normally do a graph, right, where you make a table, right, we'll plot some points. But again, connecting the dots is going to be a little bit different because of the shift in how we graph things, right? Because in rectangular coordinates, you're kind of always connecting the dots from left to right. But with polar, our x is no longer like the independent. It's our theta that's independent. And so instead of imagining going left to right like x does, right, because that's our independent, we're going to be rotating around the pole like which is what our theta does, right? It rotates around the pole. Okay, so we'll start with an easy one, all right, and then we'll do another one, like another 2 that are more interesting too, because the easy ones aren't necessarily as interesting. So let's start off with an easy one here, and I think I've got the right thing. Yeah, and I'm seeing like numbers here. That could be. Is this? Well, all right. We'll just see. Let me just check on one thing here real quick, just to make sure I'm not gonna. Okay, no. Okay, perfect. Well, no, wait. 23, 28. Oh shoot, that is the. Okay, hang on. This is the wrong paper. One moment, please. One moment, please. There we go. Here we go. Okay. Okay. All right, I'll just do this. That's fine. So, polar graphs, key thing to remember here, right? Yeah. I was about to do the homework questions for you. I'm like, wait a minute. Our theta, right, are how we label our coordinates there, but remember that theta we treat like the independent variable, which is so it's in the opposite position from what you'd expect. Okay? So normally, right, our independent variable, or the number that we choose in our table, is the first number, the x. And then it's the y that is the dependent. In this case, it is flipped around. We want to pick thetas and then find the matching r values. Bless you. Okay, that's the way to go. Bless you again. So let's start by graphing r equal to 8. R equal to 8. Okay. Let's start by graphing r equal to 8. So let's make a table. All right, and again, because thetas are independent, I'm going to pick theta as the first column of my table, which is a little confusing because again, it's the second number in the coordinate there. But yeah, I know. It's okay. It'll be all right. Okay. So pick some values for theta, right? What numbers can we pick? We can pick like 0. We can pick like pi over 6. We could pick like pi over 2, and let's pick that like pi. And that's good enough, I think, for right now. I think we'll get the idea. Okay? Because no matter what we pick for theta, what's r always going to be? 8. Okay. So okay, let's go about plotting these points then. So again, we have our concentric rings here, right? I'm going to go ahead and count every ring as 1. Okay, as a single unit there. And we'll just plot these points. So we have the point, well, 0, 8. Okay, so again, angle of 0, and then 8 out from the pole. Okay, and then pi over 6. There's pi over 6. So again, there's our angle pi over 6, and we're going to go 8 out. So 1, 2, 3, 4, 5, 6, 7, 8. Right, okay, and then 8, or pi over 2, comma 8, right, all the way up here. And then pi 8 all the way over here. And in fact, no matter what we pick for theta, our value will always be 8. And so what kind of shape are we going to have here? It's a circle. That's right. It's a circle with a radius of 8. R equals 8. Okay, so this is kind of like the horizontal line, I guess you might think of it. You know, it's kind of like fits with that. Okay, and so there's the graph. It's just the circle. Okay? Okay. Now, let's do the other way then. What if we had like theta equals, and I don't know, I'll just say like 5 pi over 6. Okay? So right, that is going to be a line, right? So now if we graph instead theta equal to 5 pi over 6, well, our theta is always going to be 5 pi over 6. So I can just kind of, you know, that whole column will always be 5 pi over 6. And then what kind of r values are we going to have, right? Well, any r value. So that includes both positive r values and negative r values. So, you know, we can say like 1, 0, negative 1, 2, negative 2, whatever you want to say in there. Okay, so yeah. You're good?
So it's kind of like the x-axis?
What's kind of like the x-axis? Sorry.
Every ring?
In a way, I would say it's more like the ring is more like the y-axis, I would say, maybe. And then like something like that. Yeah. I mean, the basic plotting, Laura, that we do for these points and stuff like that is you locate the angle first, and then you go out that many rings according to the r value. Okay? Oh, look at that. Always what I wanted. What I always wanted. Recycling. Okay. So, right, and so Ro's right here. So we're always going to have, oh, wow, a lollipop.
A lollipop.
Sorry. So 5 pi over 6 is this direction. Okay, and it's going to be any r value. So basically, you know, all these little points right here. Do we stop at the pole?
No.
Why not?
Because negative.
Right, because we have negative r values that would go in the exact opposite direction from that 5 pi over 6. And so we're going to also have these as well. Okay? Kind of looks like a no symbol, you know? No smoking. No polar graphs.
Just for that reason.
Okay? So that's your basic, those are your basic graphs, right? Those aren't very exciting, especially compared to the stuff that we saw yesterday, right? Those aren't very exciting, right? A circle and then your line. Okay? Now, on a globe, right, on the Earth, again, if we're looking at a pole, which...
It would be a circle.
Right, so both would actually end up being circles. Yes, both are going to end up being circles here. Yeah, let me see here if I can get... Oh, right, I'm not connected to the Wi-Fi. I'm sorry. So let me get connected here real quick. And I'll just show you what I was talking about. In case you guys weren't able to picture what I was talking about yesterday. I was able to look one up.
Like you just kind of start.
Mr. Wynn,
What?
who gave you the beautiful card as your photograph?
Why, that would be Natalie, of course.
Oh my gosh, yeah, the creative writing class.
That
Yeah,
is-
it's
that is
beautiful,
so
isn't
funny
it?
and so
Yeah,
cute.
yeah. She even like cut out a little graph and put it there.
Yeah, it's kind of funny.
It was very, very, very topical too because I just said something about it yesterday. So
I couldn't
she's
see
on
anything
it.
about it, but I feel like I can see the twin, and I'm like, I can't read it. I could see the twin. I'm like, I can't tell. I can't read it. Natalie, this is so cute.
Sorry, I can't read force upon.
Miss Schultz was freaking out about it. She was like, "You're so talented, Jay."
All right, so here's what I was talking about yesterday with the polar graphs and stuff. So there, again, like just what we have. There's the North Pole. You can see concentric rings for the latitudes, right? And then your longitudes are, well, the straight out right there. So that's your polar graph. Yeah, exactly. So that's how we do it, right?
This is just like something that actually means something.
It's right, exactly. Like, wow. I feel like it's worthwhile, except, most of us aren't probably going to work with that. But anyway, yeah. So, but there it is. Sorry, let's continue on here, though. Let's do one more graph. I think I fit one more graph on here. But if you don't want to fit one on there, that's fine. You can put on another one. All right, r equals 4 sine theta. So now let's put in some actual, interesting stuff that's happening here. Something that maybe we couldn't just guess off the top of our heads what it's going to be. So we'll say 4 sine theta. Okay?
Let's say that theta equals pi.
So, we'll start with 0 and kind of work our way through that first quadrant there, and then hopefully we'll get kind of an idea of what it's going to be after we get that. So that's what we'll do, just because it'll be more kind of thorough that way. Just so you can maybe get a hint of the pattern. Okay, so we'll do 0, pi over 6, pi over 4, pi over 3, the classics, right? And then we'll do a pi over 2 as well. And we'll see how much we get just from that alone. Okay. Ugh. So, we'll plug in 0 for theta, right? So what is sine of 0? 0 times 4 will still be 0. Okay. And then, let's see, pi over 6. Sine of pi over 6 is 1/2, right? Times 4 will give us 2. Sine of pi over 4 is root 2 over 2, but times 4 will be 2 root 2. Okay, which do I have a decimal? I don't have a decimal approximation there. Yeah.
Sine of pi over 6 is 1/2, right?
Sine of pi over 6 is 1/2 times 4 is 2. And then sine of pi over 3 is root 3 over 2. Times 4 will be 2 root 3. And then pi over 2, sine of pi over 2 is 1 times 1 is, or times 4, sorry, is 4. Okay, so you can see what's happening to our r values here as we rotate counterclockwise from 0 degrees up to 9 degrees, or from 0 radians to pi over 2 radians. What's happening to our r value? It's extending, right? It's getting longer as we go. So what's happening here? Let's plot the points. So 0, 0, where is that point located? It's located at the pole, right? I better put this in red, right, to be consistent here. Okay, and then at pi over 6, we're at 2. So there's pi over 6. All right, so 1, 2, there's that. Okay, and then pi over 4 is at 2 root 2, which, let's see here, do I have a decimal approximation for that? Okay, it's 2.82. So we'll say like 2.8, okay? So, and I'll put that right here.
Are we allowed to use a calculator?
That's a good question. When it's going to be non-unit circle stuff, yes. Oh, I see what you're saying. For like this kind of thing, yeah. For this kind of thing, we kind of have to. Just to kind of get a good estimation and stuff like that, I'd say, yeah, it's okay. So 2 root 2 is about 2.8. So again, there's pi over 4. So we're going to go out 1, 2 rings, and then almost to the third one, but not quite, right? So something like that. Okay, and then 2 root 3, 3.46. Let's go ahead and call that about 3.5. Not quite 3.5, right? So in the direction of pi over 3, we'll go 1, 2, 3 rings, and then about halfway, but just a little less. Right there. Okay? And then finally, pi over 2 is exactly at 4, which is a nice, easy one for us to do. So 1, 2, 3, 4 rings, and there's a point. Okay? So, right, so something's happening here, right? It's like it's curving around. And so now when it comes to connecting, it's a little bit harder. This is getting a little bit more challenging to connect these, right? Because we don't want to just draw straight lines to connect these things, right? The polar coordinates tend to have like curves and things, or polar graphs tend to have curves and things. And let me also explain like kind of why that is. So if you think about it here, we're going from a angle of 0, right? This point was an angle of 0, right? Theta was 0, and our radius was 0. So this is at an angle of 0, okay? We are 0 out from the pole. But then as we rotate, as we turn from 0 to pi over 6, so as we rotate around from 0 to pi over 6, we are changing an r value from 0 to 2. And so most likely, as we rotate from 0 to pi over 6, we hit all of the r values between 0 and 2. Okay? So as we rotate from 0 to that pi over 6, we're going to hit all these r values. So it's going to look something like that. Okay? We're going to hit all the r values extending from 0 out to the 2 there. Okay, so we don't just draw a straight line. It's going to like gradually kind of like extend out to those, that 2 there. And then we'll just continue around. From the pi over 6 to the pi over 4, as we continue rotating, we're going to continue to extend from 2 to 2.8 there, like so. And then to the pi over 3, as we continue to rotate, we're going to extend out further to the 2 root 3. Okay? And then pi over 2, continue the rotation around all the way up to the 4 there. Like that.
Let's do the next thing.
Yeah, so what we'll do now, but here's the thing, right? So sine in first quadrant, okay, how do like the corresponding values compare in the second quadrant?
They're like flipped.
So it's flipped, right? So all the y values are going to be the same. So in other words, the reference angle for 2 pi over 3, which is pi over 3, we're going to have the same values because sine of 2 pi over 3 is the same as pi over 3, right? Sine's positive in the first and second quadrants. And so at 2 pi over 3, we're going to have the same value as pi over 3, so 2 root 3. At pi over 4, we'll have then the same at 3 pi over 4, and at pi over 6, we'll have the same at 5 pi over 6. And so we don't need to recalculate here. They're going to end up being the same values. Okay? So 2 pi over 3 will be back at that 2 root 3, which is about 3.5. Well, I could have put that right here. About 3, well, let's say 3.46, we'll say. Okay. So 2 pi over 3, again, count out 1, 2, 3 rings, and almost halfway, but not quite. So something like that. Okay. And then at 3 pi over 4, we're back at 2.8, so 3 pi over 4. 1, 2, and a little bit more, so something like that. And then at 5 pi over 6, we're at 2. That's an easy one to count. 1, 2. Buckle my shoe, right? And then at pi, what's sine of pi? 0. So at pi, we'll be back to 0. So we're back to the pole there. It is a circle.
Oh my god, it's a snowflake.
Sure. It's part of a snowflake, right? It's part of a snowflake there. Okay, but there it is. Okay, so there is our graph right there. Now, what about the rest of the quadrants? What about quadrant 3 and quadrant 4?
No.
Well, let me just walk you through it, okay, mentally here. All right, so what is sine of 7 pi over 6? It'll be negative 1/2, right? Times 4 will give us a negative 2. So in the direction of 7 pi over 6, we're going to go negative 2, which means we actually go back to, and look at that, it's that same point right there. At 5 pi over 4, it's going to be negative root 2 over 2, which will then get us that negative 2.8 when you multiply with the 4. And so we're going to go back negative 2.8 to this point. And then at 4 pi over 3, same thing. You're going to go back to back to this point, then back to this point. At 3 pi over 2, it's negative 1, so it's negative 4, so you're going to go back this way. And the same thing's going to happen here. They're all just going to go back and match up with their corresponding, points in the first, second quadrant. So essentially, we do the circle again. Okay? So if we were to do theta from 0 to 2 pi, you'd wrap around the circle twice. Okay? Once because you have all these positive r values here, and once again because all these negative r values would go back then to the the corresponding angles right there. Okay, like so. So there it is. All right. Questions on any of that? And it is a circle. It's supposed to be a circle there. All good? Just want to make a snowflake. Yeah, right. I just wanted to make a snowflake. Well, we could. That's a lot more work, though, too, I'll say. So, but I'll show you how to do one on the calculator. How about that? We'll do one on the calculator maybe or something. Okay. So, all right, let's do one more here. All right, one more fun / interesting one.
Is that the one you have?
Yes, and then I'll give you guys your assignment here. Yeah, I think. Well, yeah. All right. Yeah, we can do that. That's fine. I can do it from here. All right. So last one. No, it's okay. Wave to your friends. Wave to them. Hands behind your back. All right, so let's try one more here. We'll do r equals 1 minus 3 sine of theta. This one's going to be more interesting, I'll say. Okay. Oh, yeah, absolutely. Let me give you this one. It has a bunch on there. Oh yeah, the grade sheet. Let me get to it for you. Right quick. There you go, Seth. Okay, so again, what we'll do is we'll do that first quadrant here. And I'll go, let's see here. Okay, yeah. Okay, so again, plug them in. Sine of 0 is 0 times 3 is still 0. 1 minus 0, though, is 1. Okay, plug in pi over 6. Sine of pi over 6 is 1/2. Okay, and then 3 times 1/2 is 3 halves. 1 minus 3 halves is negative 1/2. Okay, pi over 4 is going to be a little bit trickier because we're going to have root 2 over 2 here. So it's going to be 3 root 2 over 2. 1 minus 3 root 2 over 2 is approximately... You got that for us, Jenna? Negative 1.1? Yeah. Okay. And then we'll try pi over 3. So again, sine of pi over 3 is root 3 over 2. Times 3 will be 3 root 3 over 2. So it's going to be 1 minus 3 root 3 over 2, which is approximately negative 1.59. So we'll just go and call that one negative 1.6. Okay. And then sine of pi over 2 is 1 times 3 is 3. 1 minus 3 is negative 2. Okay. So let's take a look at this. Again, we'll start with this and see how we go from here. So 0, 1. Okay, that's again, so angle of 0. And we're going to go 1 in the direction of 0. So right there, positive 1. Gosh, my marker bled through there. That's kind of annoying, but oh well. And then pi over 6, negative 1, negative 1/2. So again, there's pi over 6, but since it's a negative, we're going to go in the exact opposite direction. Oh, actually, you know what I want to do here? Let me do something else here to make, because this is going to be really tight if we do it if we do it the way I was starting here. So let's count every other ring as 1. If you want to keep it as, like every ring counts as 1, that's fine. But I'm going to count every other ring as 1 here because that's going to make it a little bit better for spreading things out and stuff like that. Okay, so I'm counting every other ring as 1. So every ring is 1/2. Sorry. So then here will be our starting point, 0, 1. Okay, sorry. Pi over 6, in the direction of pi over 6, we'll go negative 1/2. So that means we're going to go back from the pi over 6 to this point right here. Okay. And then let's see here. Pi over 4 will be at negative 1.1. So again, at pi in the direction of pi over 4, but wait, it's negative, so we're going to go in the exact opposite direction towards the 5 pi over 4. So there's negative 1 and just a little bit more, so something like that. Okay. And then in pi over 3's direction, but in the exact opposite because it's negative 1.6. So we'll go back, again, 1. There's 1.5, so 1.6 would be like a little bit more. And then finally, pi over 2, negative 2. So again, there's pi over 2, but in the exact opposite direction. So 1, 2, right there. Okay, so we'll pause right now just real quick. Any questions up to this point?
Can we do the pi over 4?
Yep, pi over 4, sure. So pi over 4, right, you aim in the direction of pi over 4. Okay, but because the r value is negative, we don't go towards pi over 4. Because it's negative, we'll go in the exact opposite direction of the pi over 4. So that means towards the 5 pi over 4, we'll go 1.1. Okay? And that's true for any r value. You go in the exact opposite direction from that, angle. Now, here again, it's a little bit tricky, but we do have some help. So as we rotate from 0 to pi over 6, so as we rotate from, 0 to pi over 6, our r value goes from 1 to negative 1/2. Which means what r value, what important r value are we going to hit? Between 1 and negative 1/2, we're going to hit an r value of what?
0.
0, right? For sure. If we're going from 1 to negative 1/2, we had better hit 0, right? That's like the intermediate value theorem, which will become more important to you in calculus there. But anyway, so we're going to hit 0, which means we're going to go through what point here? If we have an r value of 0, where are we? The pole. So as we rotate from here, this point right here, as we rotate around to here, we have to go through the pole at some point. So you can kind of just like, do it that way. Okay? Now you should not, when you're rotating here, as you make your curve, don't make it too curvy, because if you curve it out too much, if you cross that pi over 6, you've gone too far, because at pi over 6, we should be down to that negative 1/2 there. Okay, so it's going to kind of like, it's like a shallow curve there. You shouldn't cross the pi over 6, because at pi over 6, you should already be at the negative 1/2. Okay? So you want to make kind of a shallow curve there. Okay? And then it's kind of obvious how we continue to rotate, right? I mean, you're just going to hit the next point, and then the next point, and then the next point, like so. Thanks, sir. Okay, now we're dealing with sine again. So at 2 pi over 3, well, that's going to be the same as pi over 3, because, again, sine of 2 pi over 3 is going to be just like evaluating sine of pi over 3, and then times 3, and then 1 minus that answer is going to be the same thing. So this is still going to be the same as 2 pi over 3. This will be the same as 3 pi over 4, and this will be the same as 5 pi over 6. Okay, so we can use all these all over again. So at 2 pi over 3, up 2 pi over 3 will be at negative 1.6. So again, rotating around, there's 2 pi over 3, but we're going the exact opposite direction here, and we'll go out negative 1.6. So there's negative 1, 1.5, and 1.6 will be something like right there. Okay? And then at 3 pi over 4, again in the exact opposite direction, we'll go 1.1. So there's 1 and 0.1, just a little bit more. All right, and then at 5 pi over 6, will be the same as pi over 6. So at 5 pi over 6, we're going to go in the exact opposite direction, negative 1/2. You can see the symmetry, right? You can see the symmetry of the points. Symmetric there. Okay, like so. And I guess I could also do at pi, it's going to be just like 0, so we get 1 as well. Okay, at pi it'll be just like 0, so we're going to get 1 as well. So we're going to go back to the pole there and back out to 1. So look, actually something like that. Okay. We're not really satisfied with that, right?
I want a swirl.
Yeah, we're not satisfied because it doesn't look done yet, right? I mean, it looks like it should kind of continue, and well, we are, because we've only hit quadrants 1 and quadrants 2 here, so we also need to think about quadrants 3 and quadrant 4. So I'll do those here real quick for us. So we'll have the 7 pi over 6, 5 pi over 4, and then 4 pi over 3, and then 3 pi over 2. Okay, and I won't need to recalculate 5 pi over 3, 7 pi over 4, or 11 pi over 6 because they're going to match up just like the first two quadrants did. And so in other words, 7 pi over 6 will be just like 11 pi over 6. 5 pi over 4 will just be like 3, or, oops, that's what 7 pi over 4. 7 pi over 4. So 5 pi over 4 and 7 pi over 4 will be the same. And then 4 pi over 3 will be the same thing as 5 pi over 3. Okay, and then 3 pi over 2, well, it'll be unto itself there. All right. So 7 pi over 6 will be negative 1/2 times 3 will be negative 3/2, but minus negative 3/2 will be plus. So we get, what, 5 halves there, I think? Is that right? 5 halves, yes. Okay. And then plugging in 5 pi over 4, we get 1 plus 3 root 2 over 2. And then plugging in 4 pi over 3, we're going to get 1 plus 3 root 3 over 2. And then plugging in 3 pi over 2 will be 4. Okay. So then our decimals for the 3 root 2 over 2 is about 3.1. Okay. And then for the 3 root 3 over 2, it'll be about 3.59. So we'll say about 3.6 there. Okay. Just like so. Oh, 5 halves, yeah, 2.5.
So how many values will there be
Great question. So, I mean, I would suggest that 0 to 2 pi is probably like is the maximum, the most that you'll need for our purposes. Depending now, Laura, if we look, if you were to change the period here, right? So if I put like a 2 in there, that would then adjust the period. So you have to adjust, kind of like what.
Where you would start.
How well, yeah, it would adjust the period and like not only where you would start, but also like how long or short it needs to be, kind of thing, right? Just in the same sense we've done before, how it shrunk or stretched the period, kind of thing. That's what we would need to adjust. But since the period's just the normal, 0 to 2 pi, we'll just go 0 to 2 pi, and that should give us the full picture there. Okay, and so let's just finish it off here. So after this pi, we went to 7 pi over 6, and 7 pi over 6 is going to go exactly 2.5, so that's nice. So again, don't forget, every ring is half. So 1 half, 2, 3 halves, 4, 5 halves right here. Okay, and so we're going to continue our arc around there. And then at 5 pi over 4 will be 3.1 in that direction. So 5 pi over 4, 3.1. So 1, 2, 3, and a little bit more. And then at 5 pi over 3 will be at 3.6. Or sorry, 4 pi over 3, 3.6. So let's see here. 1, 2, 3. There's 0.5, so 0.6 will be a little more. Okay, and then finally 3 pi over 2 will be 4. So 4 in the direction of 3 pi over 2. So 1, 2, 3, and wow, it just fits. Okay. And so then 5 pi over 3 will be the same distance out as the 4 pi over 3. And again, you can kind of see the symmetry here. Use the symmetry to your advantage there. Don't feel like you have to, kind of recount everything here. We can just use the symmetry to our advantage to get this. Because in calculus, and yes, you'll be doing calculus with these polar graphs if you choose to do A, B, B, C, you will I like to think of it as like a cross section of like a peach. Like there's the pit, and then there's like the stuff you eat.
Yeah, well,
Yeah?
I don't see it as a
Peaches. I like to think in terms of food. So. Okay. And so there's our graph. What are we going to call it? I believe this is under the classification of a cardioid. A cardioid because it has a rough resemblance to a heart there. Yes. Yes. It could be an earring. Yes, exactly right.
I don't know what I see.
Too bad I don't wear earrings. I could have polar graph earrings, That could be maybe like a pendant or something like that, a chain.
Yeah, but 1 minus 3 sine theta.
Yeah, exactly. Yo, but you see the 1 minus 2 sine thetas? Those look even better, So, all right. So there it is, okay? That's it. Is that it? That's it. All right. So for the rest of the time, all right, you can practice some more here. I've got some additional graphs for you for the homework. You will be graphing on the test. So you want to make sure you're good with this. So page 789, numbers 23, 28, 29, and 33. Okay? I have the answers up here too. The test will be Friday when you come back. So Wednesday and Thursday we'll be reviewing in preparation.
What is the thing when we come back? What's on the day that we come back? What's the PS work day?
That's like a problem set for some practice.
Okay, are you able to post the picture view?
So what?
Are you able to post the picture view packet on the break? Is there if anyone wants to work on it or start it, we can.
Oh yeah, I can do that. Can do.
What are we doing, trash bin? We're doing any trash in here?
Right there, we
I'll just
could
do it like this.
$200.
I mean, we're not supposed to.
Can I just sign up for something, Mr. Gills?
Go ahead.
Did you see Mr. Gill's awesome singing this morning? Did you see Mr. Gill's awesome singing this morning?
Oh, did he sing? I thought I heard.
Yeah.
Was it just him?
It was him and then the band.
Okay, yeah, he sounded good.
It did sound really good.
I was like, dang, who is that? And okay, now I know.
It's really funny because I'm like, I hear and see Mr. Gill in the hallway, and then I go to the elementary school and then see his father in the hallway.
Oh, that's funny.
I love when I do that. It's always cute.
Yeah, it is good, isn't it?
Are you posting the homework from last night? When you
Um,
said, where can find it?
I don't know where it is. I've lost it. Lost my marbles.
Very elegant.
Thank you. I almost popped out. That was beautiful. I popped out. Oh, I would have to.
Are those smelly shell things? Does it really smell like something?
Yeah, that would be real.
Are those smens?
Yes.
Ah.
I have never heard them.
Wow.
I've never heard them called that before.
Oh.
Sure.
Well, there's a company that actually makes them, and they call them smens. And then there's also smensels too, and they're like smelly
Yeah,
pencils.
those are strawberry, blueberry, and grape.
So if you're hungry in class, you can.
No, that makes it worse.
I see.
He knows.
Yes, I'll get you another one here. Let me just sniff these markers real quick. Yes, that smells like grape. Ooh, that does smell like strawberry.
I like the blueberry one.
I love smelling
Yeah, it's weird.
The blueberry one is,
Do we keep these?
yeah, interesting. Interesting.
I like them.
Keeping these tests?
Yes, you may.
I
All right,
want them.
Laura.
Tara.
I'm gonna do that here real quick. Turn off this.
The way you just said my name, like, kind of offended me.
Kind of offended you?
You're like,
Laura. Laura. Laura.
my, in preschool,
Laura.